the theorem of division algorithm. The theorem of division algorithm states that, or the theorem of division algorithm says, if there is the integer, we have given the integer a and b are the two integers where a is less than 0, then there exists unique integer. There exists unique integer q and r such that b equal to aq plus r, where 0 is less equal r is less than 2. The meaning of theorem is that suppose 5 divides 22, then 5 divides 22 is 4 and remainder is, if 5 divided 22, then we get remainder is 2. Then remainder is 2, and 2 is always less than 5. 2 is always less than 5. Then we can write 22 as 22 in the form of 5 into 2, 5 into 4 plus 2. Here 4 and 2 are the units, because we only write 22 in the form of 5 into 4 plus 2. We cannot write 22 as a 5 into 6 plus 3, because this multiplication and addition get wrong value. Therefore, this multiplication not equal to 22. Therefore, we can write 22 in the unit form, which is 5 into 4 plus 2, if we divide 22 by 5. Okay, this is the meaning of theorem. Here, B is 22, A equal to 5, Q equal to 4, and R equal to 2. Then we can write B equal to A into Q plus R. And here R is always less than B and greater than or equal to 0. ये हमें प्रूव करना है, ये हमें दिया है. हम theorem we have given that B equal to AQ plus R. Then we have to show that 0 is less equal R and less than E. ये हमें प्रूव करना है. Okay. Now see the proof of theorem. First proof here, proof of theorem. To prove the theorem, consider the sequence. Consider the sequence. Consider the sequence of multiple of A. Then the sequence of multiple of A, 0, A, 2A, and so on. And here minus A, minus 2A, and minus 3A. This is the sequence of multiple of A. Now consider case first. Consider the case first. If A divides B, then by definition of by the definition of divisibility, we can write B equal to A into Q, where Q is any integer, Then by in theorem we have given that we have given that in the theorem we have given that B equal to AQ plus R. Then say this equation as 1. Then comparing B equal to AQ plus R with equation 1, we get R equal to 0. Then we get R equal to 0. Okay. If in case first we take A divides B, then we get, by the definition of divisibility, we get B equal to AQ, and we comparing V equal to AQ with given V equal to AQ plus R, then we get R equal to 0. Consider case second. Consider case second. Suppose A does not divides B. Suppose it does not divides B, then this means that B lies between two consecutive multiple multiple of A. Suppose B lies between AQ and AQ plus 1. Then you can write AQ less AQ, then you can write AQ less than P less than A into Q plus 1, because our B is lies between two consecutive multiple of A, and these two consecutive multiple of A are AQ and A into Q plus 1. Therefore, we can write it AQ less than B less than AQ plus A. Okay, AQ plus A. Then subtracting AQ from all the system, we get AQ minus AQ less than B minus AQ plus, sorry, here AQ A into Q plus A into Q. Here AQ minus AQ less than B minus AQ less than AQ plus A minus AQ. We get 0 less than B minus AQ, which is less than E. This is less than E. Say it is as 2. Say it 2. But our theorem given, we have given that, theorem given that, but we have given that B equal to AQ plus R. From this we get R equal to B minus AQ. Put R equal to B minus AQ in equation 2. We get, if you put R equal to B minus AQ in equation 2, we get 0 less than R less than A. This is our proof. हमें यही दिखाना था कि R lies between 0 and 1. Then from case 1 and case 2, we get 0 equal to R and 0 less than R less than A. These two, by these two we get 0 is less equal R less than A. Here हमने प्रूव किया है कि there exists Q and R such that 0 is less equal R and Q. Now हमें प्रूव करना है कि there exists unique. हमने ये शो किया है, देखो अभी हमने दिखाया कि Q and there exists, हमने अभी ये शो किया कि there exists Q and R. Now we have to show that Q and R are unique. हमें Q and R unique दिखाना है. For to show the uniqueness of Q and R, consider there exists there exists there exists integers q1, q2, there is integer q1, q2, r1, r2, such that b equal to a into q1 plus r1, where 0 is less equal r1 less than a. And now second, consider b equal to a into q2 plus r2, where 0 is less equal r2 is less than a. Put value of b from this equation in this equation. We get a into q1 plus r1 equal to a into q2 plus r2. A into q2 plus r2. r2. Then we get this two equation. We get r1 minus r2 equal to a into q1 minus a into q2 equal to a into, take a as a common, we get a into q1 minus q2. This implies that r1 minus r2 equal to a into q1 minus q2. But by the definition of but by the definition of divisibility, by the definition of divisibility, we get but by the definition of divisibility, we get we get a divides r1 minus r2, because in the divisibility, if b equal to a2, then this implies that a divides b. This is the definition of divisibility. We use definition of divisibility in here, then we get a divides r1 minus r2. A divides r1 minus r2. But this is not impossible, because 0 is we take 0 is less equal r1 less than a, and we take 0 is less equal r2 less than a. Therefore, a does not divide r1. Therefore, a does not divide r1 minus r2. This implies that r1 equal to r2. This implies that this equation is wrong. This is not possible. Therefore, जो R1 एंड R2 लिया है वो गलत है. हमारा R1 एंड R2 क्या होगा, सेम होगा. दिस इज द यूनिकनेस ऑफ R1 एंड R2, एंड दिस इंप्लाइज दैट हमने जो Q1 Q2 डिफरेंट लिया था वो भी गलत है. तो हमारा Q1 और Q2 क्या होगा, सही होगा. दिस इज द यूनिकनेस ऑफ R1 एंड R2, एंड दिस इज द प्रूफ ऑफ आवर theorem. Okay, this is the proof.